Alright, so welcome to day 7 from Advent of Code 2015. I think though today we have a easy one, a little bit to code to understand, but easy. So today we will have to build a simulator or to simulate a circuit, and the circuit has a wires and bitwise logical gates like AND, OR, NOR, or whatever gates we have. And then for this one, the wire has an identifier, so each identifier is small case letters, and also the wires can carry a 16-bit signal. So it's from 0 to 65535. It's unsigned signal, unsigned int. And these signals provide for each wire by 3 ways. So even the output of a gate, or from another wire, or from some specific value like 1, 2, 3. And each wire can only get a signal from one source. So the wire could have one source of value and could provide the value to multiple destinations. And also the gate cannot process the signal until all the input has a signal. So if in case we have X and Y give the signal to Z, this gate cannot be processed until the X and Y both has values. And yeah, so X and Y goes to the input of and then the output goes to Z. And we have also, yeah, this is example. And P left shift means that the value from the wire P is left shifted by 2 and provided to the wire Q. We will see what does this mean. And also the bitwise complement for the wire. Okay, we have also OR, we have also right shift. So I think this is straightforward, like all programming language has bitwise operation including Go, so we don't need to do any code for converting from int or to binary and then do this operation by hand. And they give us an example, and this example, these wires should have these values. Okay, so let's check Wikipedia. So first of all, we need to check the bitwise operations. So I really recommend to read these pages. They are really helpful, especially for somebody who don't have who they don't have like computer science background, or they don't read about this logical operation or so. For this one, we have like each number is converted to binary, and then we do the operation on the binary level. So for example, the 7, if we do the operator not on the 7, we don't do it on the 7 directly, but we convert it to binary, and the 7 in binary is 0, 1, 1, 1. And then we do the complement. The complement is we flipping each bit. So we have 1, it became 0, and the 0 becomes 1. It becomes 1, and then we have 1, 0, 0, 0, and the complement or the not to the 7 is 8. And this is for 4-bit for 4-bit system, and for 8-bit system it's different, and so on. And for an AND gate, so for AND gate we have so it's binary AND, so it's a gate. We have 2 inputs, and then if the input with the 2 inputs has a signal, or like 1 and 1, then the output has a signal, otherwise it's 0. And also the OR, we have the OR, so if it's one of them has a signal, so both of them, if one of them has a 0, has a signal, or 1, so the output has a signal. So I really recommend to write. Also, there's some information about the logical shift, so how we do the shifting. So this is the operator that we use in programming languages. It's really like almost similar. So what we do, we shift all the numbers by 1 to the left or to the right, depending on the value, like 1, 2, 3, 4, depending on what we need to shift. And then we fill up in the least significant bit or the front, we fill up with zeros. And if we do the right shifting, we put the zeros at the end of the number. and this is important to understand, or like just if you have interest. And yeah, so let's go to the coding. For this one, I already created the solution file. It's empty solution file. I created the init file, the init function. As always, we registered the day and then added the solve function. So I didn't do anything, just read over the input that we have. And in the input file, I just put the example that they provided us. So how to proceed with solving this problem? So the first thing, we need to parse it to a form that it's easy to understand or easy to work with. And the best way is to create a type or struct type instruction, and it's type of struct. Okay, so the instruction has multiple parts. The main part is a wire, so the output of the instruction, and then the instruction itself. So the instruction itself has also multiple parts. It has the for example, this one, it has the left part, it has the operator, and it has also the right part. So it has two parts. And in case the value is a real value, so we will imagine that we have this operation, so something assigned, and we have it, we would say like it's empty. We could have it as just have right operator, and also the not doesn't have left, so it has only right operand. So how we will do it? So let's say like it has a left from string, and also it has the operator also from string, it has right from string, and it also has the wire, so the wire also from string. So what we need to do, we need to split this string to something readable, like readable to us, it's easier to understand. So what I am suggesting, maybe for this one we only have single operation, which is right operation, so just the right part, and not have only the left part, and for each of the others has left and right parts. So let's start by parsing. We create a simple function called parse. Think the simplest way, remove insert parse. We need to parse the line, and we need to send back instruction. So the best way to do it is to have split it by the assign first. So let's say parts strings split, we split by this, and in this way we will have two parts, always two parts. The second part is always the wire. So this is the second part, or part one, and then depending on the part one that we part zero. So for this one, for example, we have only one, and in case also the wire provided to a wire, we also have it as 1, and in case of not operator we have 2, and the other ones we have 3. So let's say like we have tokens, we can do split by spaces. So we can split by spaces, but this is really not a good idea, because we will have something like a, then we will have a space, empty or empty, then we will have and we have to deal with this slice with empty elements. What we can use something better, which is in Go strings.fields, which is remove all these empty spaces from the split, and give us like just the fields, like it's a, and then it give us or x and y, it give us only 3. So we need to parse the part 0 all the time, and then if the tokens or the links of the tokens, equals 1. So this means direct assignment 1 to 3 to x or y to x, and this will give us instruction which has the left part is the value of the token, and then the operator, sorry, it's empty operator, and then what will give us the right part is empty, and then the wire is the wire value. So this is what we will have. Else, if the length of the tokens equals 2, this means that we have not A goes to Y or not 2 goes to C, for example. And in this way we have to return instruction which have the value left is empty, and then operator is tokens 0, and then right is tokens 1, and the wire is wire. Else we have all the other cases like A and Y equals Z or whatever, anything else. So we shift to C X. What we need to do, we need to have a normal instruction with all the parameters. So the left is token 0, the right, sorry, the operator first, tokens 1, and then the right part is tokens 2, and the wire is already passed. So this is what we need to do. And here we have, let's have instructions, which is slice of instructions, and start, let's have it with a 0, and then instructions equals append instructions with parse line. So let's try to visualize it if it will work. And then instructions. Oh yeah, seems correct. Like this is the value and x, x, y, x and y. Okay, looks correct to me. Yeah, this one, that's what I've added. Looks correct to me. Okay, so let's go with the solving. So let's do it. What we do to solve it, we need to try to solve each wire. So the instruction, we cannot solve the gate unless both inputs are solved. So in this case, to solve x shift 2, we cannot solve it before finding the value of x. And let's say we have something like H and J goes to V, for example. We cannot find the V value before finding the J and the H value, and the H and J value we cannot find the value before finding the X and Y value, and so on. So this is really important in our case, and for this one I will just rename it try to solve the instructions, or actually process instructions, better. Instructions, it's a slice of instructions. So what we will do, we will have a map. So the best way to do it, we have a map which we map string 16. So the integers or the values of the signals are 16-bit signals from 0 to 65535. So in this case we need to use uint in Go. So u is for unsigned bits and int 16 for 16 the length of 16 string, and the array we will put on it only the value of processed wires. When at first we have no value, has no values, wires populated step by step. So how to solve it? We have to go over it in a loop for links wires, links instructions. So we have to go until all the wires, so this means until all wires has value. And for this one we have to repeat each time for instructions. So let's instruction, or I will rename it just I, it's easier to type. So for instructions, for each instruction, what we do, if the wires map has the value of the wire, what we will do, we need to skip this continue. We need to skip it. So we already find the value of this wire. So at the first, if we want to process these ones, so the first one is assignment. So first one is empty. So empty, we don't have any value. So we go to the next one. We start populating it with x, and then when we go to the x at the second round, we don't need to fill it. So we just skip the loop completely. And then we need to find the left and right values. So for each instruction has a left and right value, and both of them, they have to be populated to find the output of the gate. So for this one, what we need to do, like left value does left, or let's say left okay, right value and right okay. So what's the value of this one? Let's see, 0 false. So I was not able to find a way to have the in Go. I don't think it's possible to have two values for the for an element, or like so, like value and empty. So I have to use two variables, like one to hold the value and the second variable to hold the if it has value or not. So it's not left okay. So it's actually meaning does left has value. This meaning processed. So I will just name it as left okay. So for this one, when the left has a value, so if the instruction left equals empty, this means it could have a value. So this means the left value, the left okay, and the left value is 0. We don't care about the 0. This is similar to the not operator. And the second part, if the left has if the left has a value of integer, so if we have something like 1 2 3 and 22333 goes to Z, for example. So in this case we have to parse it as to parse it first before we process it. In Go, how to process it, we use the string convert. So error, we have strings dot str convert dot r to I, and then we process the value. If the value if there's a value, so if there's no error, what we will do, we return, not return, sorry, we do left value equals to the number, and the right value, the left value is okay, left okay, so equals true. And then the last part, if we find the, so if it's not not a number and it's not an empty, so it's supposed to be wire. So if the wire has a value also, so we have to check in our map here. So what we will do, so we will have the value of the wire, and then we will have the found, so wires I dot left, and then what we will do, if found, this meaning that the left value equals the value of the wire, and then left okay, so the value is processed already. Otherwise, actually we could simplify it, we could just have the left value equals found. So this is options for the left value to be processed. And then I think with a similar thing, process the right value, right value. So if the right, then right okay, and then right, and then right value, right okay, then we have to check here for the wiring for the right, and then right value, and then right okay. So I think it's straightforward. We have now, so this is meaning that does the wire or the value processed, and this is processed, and then we will go with the operator. So here process the actual operator, so we need to do switch case for the operator, it's capital letter, okay, so case empty. So case empty, so this is meaning as we said before, like 1 2 3 goes to X, or this is meaning another wire goes to X. This is direct assignment, so if left okay, we just assign the wires with the left value. That's it. I think that's it. Easy. And if it's not, the not operator needs right value only, so we don't care about the left value. So if right okay, we have wires, so the value of the so the not operator or the bitwise operator for not in Go is this one, so we use this one, right value. So is bitwise not in Go. So this is for not, and then we go for case and. So for and, it's all the cases like something, something, and some other thing. some other thing. So we need both signals to be processed. So if left OK and right OK, wires wire equals right left value and right value. So what we need to do, this is the single ampersand is the bitwise operator in Go, and the double is the logical operator. So this is logical and this is bitwise. So much information in this video. Case or what we need to do, if left OK and right OK. So also for OR we need both of them. So where's wire? So let's copy it, it's easier. And this is the OR, and then we need to copy also to do the same for the left shift, left shift, and then the left shift we need also. For the left shift actually we need only the right value if the right is OK, and the left shift we will do something like we use this one. No, actually we need both of them. We need both of them. And then for right shift we have it in the opposite direction. So I think that's it. Hopefully it will be processed from the first one. So let's print the array at the end, see how it will goes. For key value and wires. So string and the value is decimal key value. Let's go /n. So what we will do, let's process all the wires, see how it will goes. So process instruction, let's remove it and do process instructions 1 2 3. Yeah, so I don't know actually if this is correct. So the E has a value 507. Let's go. E has 507, it's correct. Let's see I 65079 65079 492. It's 492. It's correct. So I think it's correct. So let's see the output of the puzzle. This is the normal output. Ah, yeah, but what they need. So I forgot to check what they need. So little Bobby instruction. They need the value of the wire A. So the value of the wire A is the value of the wire A. So what we need to do actually, we need to process instruction and we need to send something like A, and then we need to get the part 1, something like this, and then we need to put something like wire from string, and then we need to send the value. And then I think here what we need to do, instead of using the for loop, I will just comment it, I will do something like value of value or v, and found wires wire, and if found return v. Panic, unable to process value of where. Oh, it's not like this. It doesn't work like this, I think. Oh, let's wire off. Yeah, it works like this, and we return it. Okay, let's part 1. Oh, part 1 value of b of a decimal, and part 1, let's go one line. Oh yeah, 16076. I don't know. Let's copy it. Let me check just a second if I'm recording. Yes, I'm recording. Correct. Yeah, it's good. Correct. So we have first one. Well, the second one. Okay, now. Okay, so part 1 is done. Part 2. Now take the signal that you got on wire A, override wire B to the signal, and reset the other wires including wire A with a new signal. It's unlimitedly provide. Okay, so I think, what does this mean? Part 2. For part 2, what we need to do, I think, we need to search for the instruction that has a wire A, and change it with change the value of it to the new wire, to the previous one, and then we process it again and get the value of A again. So I think this is, so let's how to change it. So we have to go for instructions, range instructions. What we will do, so if the wire is A, we have, I'm not sure if this work, that wire, so left, so okay, so the left supposed to be, let's see like how it is said, like so does this mean that change this one with A? No, I don't know, like override the wire B. Override the wire B. So if the wire is B, let's see for B. Where's B? Yeah. The B has a different value, so we need to override it. So as we process the single assignment, it's B, so we need to convert it actually. So str convert from integer to A, and then we need to put the part 1, something like this, and the right operator is empty as it was, and the right is empty, and the wire is B. So in this way we override it. Actually we need to use the index, so index instruction. We cannot use it, so instruction index instructions. Okay, instructions at index 0i. Okay, I think it's correct. Let's do part 2. Process instructions to get A, and then part 2 value of A, D, part 2. Let's hope that will work. Okay. Oh fuck, it's way smaller. Okay, let's see it. Actually it's correct. Nice. So now we are done from day 7. Next week day 8. So let's concentrate on day 7 now. So we are done from day 7. It's a long video. See you in day 8.